transient voltages can cause electronic failures in plasma cutters. Several strategies can be implemented to mitigate these issues. Firstly, grounding and shielding are critical. Ensure the plasma cutter and all related equipment are properly grounded to a low resistance path, such as an electrical ground rod. This provides a safe route for unwanted currents to flow to ground. Use shielded cables for all power and signal lines. Proper grounding of the shield terminations is essential for their effectiveness. Consider using metal enclosures or Faraday cages around sensitive electronic components. This minimizes electromagnetic interference, or EMI, which can induce transient voltages. Secondly, surge protection devices, or SPD, can be installed. Install surge protectors at the point of entry for power lines and other potential sources of transients, like lightning strikes. Select SPD that are appropriately rated for the voltage and current levels expected in the operating environment. This ensures that they can handle the surge without failing. Thirdly, transient voltage suppressors, or TVS, are effective. Place TVS across sensitive components or power rails to absorb and divert transient voltage spikes. Select TVS with appropriate voltage and current ratings and ensure correct polarity during installation. Incorrect polarity can render the TVS ineffective or even cause it to fail. Fourthly, filtering techniques can be applied. Use low-pass filters or common mode chokes on power and signal lines to attenuate high-frequency transients. Design the filters with cut-off frequencies appropriate for the expected transient frequencies. This prevents the transients from propagating through the system. Fifthly, isolation transformers offer a solution. Install isolation transformers between the plasma cutter and the power source. This provides galvanic isolation and suppresses common mode transients. Select transformers with appropriate voltage and power ratings and ensure proper grounding. Sixthly, regular inspections and maintenance are crucial. Regularly inspect equipment and connections for any signs of damage or loose wires. Tighten connections, replace damaged components, and address any potential sources of transients promptly. This proactive approach can prevent failures. Seventhly, monitoring and analysis helps identify problems. Install transient voltage recorders or oscilloscopes to monitor voltage fluctuations and identify the source of transients. Analyze the results to determine the appropriate mitigation strategies. These tools can provide valuable insights into the nature and origin of the transient voltages. Proper grounding involves creating a low impedance path for fault currents to return to the source. This is typically achieved by connecting the equipment chassis to a grounding electrode, such as a ground rod or a building's grounding system. Shielded cables are designed to reduce electromagnetic interference by providing a conductive barrier that intercepts electromagnetic radiation. The shield is typically made of a metal foil or braid and is connected to ground. A Faraday cage is an enclosure made of conductive material that blocks electromagnetic fields. It works by distributing the charge or electromagnetic radiation around the exterior of the cage, preventing it from penetrating the interior. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges caused by lightning strikes, power line faults, or other transient events. They typically work by diverting the surge current to ground, preventing it from reaching the protected equipment. SPD are rated based on their voltage and current handling capabilities, as well as their response time. Transient voltage suppressors, or TVSs, are semiconductor devices that are designed to protect electronic circuits from voltage spikes. They work by clamping the voltage to a safe level, preventing it from exceeding the maximum allowable voltage for the protected components. TVS are available in a variety of voltage and current ratings, and they can be used to protect a wide range of electronic equipment. Filters are circuits that are designed to attenuate certain frequencies while allowing others to pass through. Low-pass filters are designed to attenuate high frequencies while allowing low frequencies to pass through. Common mode chokes are designed to attenuate common mode noise, which is noise that is present on both the signal and ground lines. Isolation transformers are transformers that provide galvanic isolation between the primary and secondary windings. This means that there is no direct electrical connection between the two windings, which helps to prevent ground loops and common mode noise. Isolation transformers are often used in sensitive electronic equipment to improve noise immunity. Regular inspections and maintenance are essential for ensuring the reliable operation of electrical equipment. This includes checking for loose connections, damaged wiring, and other potential problems. Tightening connections and replacing damaged components can help to prevent equipment failures and improve safety. Monitoring voltage fluctuations can help to identify the source of transient voltages. Transient voltage recorders and oscilloscopes can be used to capture voltage waveforms and analyze them to determine the frequency, amplitude, and duration of the transients. This information can be used to identify the source of the transients and implement appropriate mitigation strategies. The specific measures required will depend on the particular plasma cutter and operating environment. Consult with the manufacturer's technical support or a qualified electrician for guidance on the most effective solutions. Factors to consider include the type of plasma cutter, the power supply voltage, the grounding system, and the presence of other electrical equipment in the area. A thorough understanding of these factors is essential for developing an effective transient voltage mitigation strategy. Consider these additional points when addressing transient voltages in plasma cutters. Firstly, power conditioning units. These units provide a stable and clean power supply to the plasma cutter, filtering out voltage fluctuations and noise. They are particularly useful in environments where the power quality is poor. Secondly, uninterruptible power supplies, or UPS. These provide backup power in the event of a power outage, and they also offer voltage regulation and surge protection. A UPS can help to prevent damage to the plasma cutter and ensure that it can continue to operate during a power outage. Thirdly, proper cable management. Keep power cables and signal cables separate to minimize electromagnetic interference. Use cable trays or conduits to route cables and keep them organized. Fourthly, regular cleaning of the equipment. Dust and dirt can accumulate on electronic components and cause them to overheat or malfunction. Regularly clean the plasma cutter and its components to ensure proper operation. Fifthly, temperature control. Keep the plasma cutter in a cool and dry environment. High temperatures can cause electronic components to fail, while moisture can cause corrosion and short circuits. Consider using a cooling fan or air conditioner to maintain a stable temperature. Sixthly, vibration isolation. If the plasma cutter is located in an area with high vibration, consider using vibration isolation mounts to protect the electronic components from damage. Vibration can cause components to loosen or break, leading to failures. Seventhly, software updates. Keep the plasma cutter's software up to date. Software updates often include bug fixes and improvements that can improve the performance and reliability of the equipment. Eighthly, proper ventilation. Ensure that the plasma cutter has adequate ventilation to prevent overheating. Locked vents can cause the equipment to overheat and fail. Ninthly, follow manufacturer's recommendations. Always follow the manufacturer's recommendations for installation, operation, and maintenance. This will help to ensure that the plasma cutter operates safely and reliably. Tenthly, train personnel. Train personnel on the proper operation and maintenance of the plasma cutter. This will help to prevent accidents and ensure that the equipment is used correctly. Implementing a comprehensive transient voltage mitigation strategy requires a multifaceted approach. By addressing the various potential sources of transients and implementing appropriate protective measures, you can significantly reduce the risk of electronic failures and ensure the reliable operation of your plasma cutter. Remember to consult with qualified professionals for assistance with specific installations and troubleshooting. Electrical transient analysis is also key. This involves using specialized equipment to measure and analyze transient voltages in the electrical system. The data collected can be used to identify the sources of transients and to develop effective mitigation strategies. An electrical transient is a short-duration, high-amplitude voltage or current surge in an electrical circuit. Transients can be caused by a variety of factors, including lightning strikes, switching operations, and electrostatic discharge. They can damage or destroy sensitive electronic equipment, so it is important to take steps to mitigate their effects. There are several types of transient voltage suppressors, or TVS. These include metal oxide foresters, or MOV, avalanche diodes, and transient voltage suppression diodes, or TVS diodes. MOV are the most common type of TVS and are typically used to protect against high-energy transients. Avalanche diodes are faster than MOV and are typically used to protect against low-energy transients. TVS diodes are the fastest type of TVS and are typically used to protect against very fast transients, such as those caused by electrostatic discharge. Common mode chokes are used to suppress common mode noise, which is noise that is present on both the signal and ground lines. Common mode noise can be caused by a variety of factors, including electromagnetic interference and ground loops. Common mode chokes work by creating a high impedance to common mode currents, which effectively blocks the noise from propagating through the circuit. Isolation transformers are used to isolate electrical circuits from each other. This can be useful for preventing ground loops and for protecting sensitive equipment from voltage transients. Isolation transformers work by using separate windings for the primary and secondary circuits. There is no direct electrical connection between the two windings, which helps to isolate the circuits from each other. Consider NEC Article 310.15. This section covers the ampacity of conductors. Ampacity is the maximum current in amps that a conductor can carry continuously under the conditions of use without exceeding its temperature rating. When dealing with sensitive electronic equipment like plasma cutters, maintaining a stable and reliable power supply is paramount. Transient voltages, also known as voltage spikes or surges, can wreak havoc on electronic components, leading to malfunctions, reduced lifespan, and even complete failure. Implementing a robust transient voltage mitigation strategy is essential to protect your investment and ensure consistent operation. Grounding and shielding form the first line of defense. Proper grounding provides a low impedance path for transient currents to flow to ground, diverting them away from sensitive equipment. Shielding, on the other hand, minimizes electromagnetic interference, which can induce transient voltages in signal and power lines. Surge protection devices, or SPD, are designed to clamp voltage spikes and divert excess current to ground. These devices are typically installed at the point of entry of power lines into a building or at the equipment level. Select SPD with appropriate voltage and current ratings to ensure they can effectively handle the expected surge levels. Transient voltage suppressors, or TVS, are semiconductor devices that provide fast-acting protection against voltage transients. They clamp the voltage to a safe level, preventing it from exceeding the maximum allowable voltage for the protected components. TVS are available in various voltage and current ratings and can be used to protect individual components or entire circuits. Filters are used to attenuate unwanted frequencies, including high-frequency transients. Low-pass filters are commonly used to block high-frequency noise from entering sensitive equipment. Common mode chokes are effective in suppressing common mode noise, which is a type of noise that is present on both the signal and ground lines. Isolation transformers provide galvanic isolation between the power source and the equipment, preventing ground loops and common mode noise from interfering with the operation of the equipment. They also offer voltage regulation and surge protection. Regular inspections and maintenance are crucial for identifying and addressing potential issues before they escalate. Check for loose connections, damaged wiring, and signs of corrosion. Tighten connections, replace damaged components, and clean the equipment regularly. Monitoring voltage fluctuations can help identify the source of transient voltages. Transient voltage recorders and oscilloscopes can be used to capture voltage waveforms and analyze them to determine the frequency, amplitude, and duration of the transients. This information can be used to pinpoint the source of the transients and implement targeted mitigation strategies. In addition to the above-mentioned measures, consider the following best practices. Firstly, power conditioning. Use power conditioning equipment to regulate voltage fluctuations and filter out noise from the power supply. Secondly, cable management. Keep power cables and signal cables separate to minimize electromagnetic interference. Use shielded cables and proper grounding techniques. Thirdly, environmental control. Keep the equipment in a clean, dry, and temperature-controlled environment to prevent corrosion and component failures. Fourthly, training. Train personnel on the proper operation and maintenance of the equipment. Emphasize the importance of grounding, surge protection, and other mitigation measures. Fifthly, documentation. Maintain detailed records of all maintenance activities, inspections, and repairs. This information can be valuable for troubleshooting problems and identifying trends. Sixthly, compliance. Ensure that all electrical installations and equipment comply with applicable codes and standards. This includes grounding requirements, surge protection requirements, and other safety regulations. Seventhly, risk assessment. Conduct a risk assessment to identify potential sources of transient voltages and to evaluate the effectiveness of existing mitigation measures. Eighthly, continuous improvement. Continuously evaluate and improve your transient voltage mitigation strategy based on experience and new technologies. Ninthly, professional consultation. Consult with qualified electrical engineers and technicians for assistance with designing, installing, and maintaining transient voltage mitigation systems. Tenthly, insurance. Consider purchasing insurance coverage to protect against losses due to equipment damage or downtime caused by transient voltages. Remember that a proactive approach to transient voltage mitigation is essential for protecting your equipment, ensuring reliable operation, and minimizing downtime. By implementing a comprehensive strategy that addresses all potential sources of transients, you can safeguard your investment and ensure the long-term performance of your plasma cutter.